All right, so the last section of this chapter I want to talk about is some different ways that we use technology and techniques to actually see and study the brain. And so we'll talk a little bit about things like research methods in neuroscience and how we actually use different tools to study the brain. So I'm going to show you a few of these here, and we'll talk about each of these. So the first one in the upper left we can see here is an example of an EEG, or an electroencephalography graph. And what this does is measure the electrical signals being sent on the outer cortex of the brain. So they use caps with little tiny electrode signals that pick up electrical signals that are being sent on the cortex, or the outer surface of the brain. And as they pick up these signals, we can kind of create these really rough sort of maps of what's going on in the brain in different portions. And one thing about EEG that it has is it has really good temporal resolution. So we talk about this here. Let me actually get rid of those. And so EEG, we say, has really good temporal resolution. And this is helpful and important because it allows us to have a really good idea of when certain signals are happening in time. And this is great for us to be able to kind of measure exactly, if we present some piece of stimuli, we can see the exact time in the response to what was given to a participant. So that's fantastic. But while it has really good temporal resolution, it has pretty bad spatial resolution. And so this means that it really doesn't have a good job of seeing where in the brain we are seeing these signals and seeing this information take place. And so while we can see when, we can't really see where as accurately. The next one over here we see is called a PET, positron emission topography scan, a PET scan. And what this does is it allows us to actually see a little bit of the activity of different neurotransmitters and actually what's going on in certain regions of the brain. Again, we can see we get a little bit more information, a little bit more maybe of that spatial resolution. And so PET scans provide a little bit more information, but they aren't quite as good in their temporal resolution. So we have sort of a medium amount of temporal resolution and I'd say a medium amount of spatial resolution as well. Then on the bottom left here, we have an MRI. For MRIs, we see really good spatial resolution. And we can really get into the fine-grained details of where things are happening. And so we can see really well that spatial mapping and where things are located. But we have really bad temporal. We're not really even measuring the functionality at all. So all we're really seeing is the structure, the physical structure. We're not really looking at anything that's going on or what's taking place at different times, different points in time. And then the last one here we have is an fMRI, which just stands for functional magnetic resonance imaging. And this is sort of the most ideal option that we have. It gives us the best of everything. It has relatively, I'd say it has really good spatial and okay temporal. What this does is it uses sort of an MRI map to provide the background of the structure of where things are located. And then it looks at what's called a bold signal, which is basically looking for blood oxygen levels within the brain and saying that if this region of the brain has higher oxygen in its blood, it's taking in more resources, it's being more utilized during this point in time. And so we can say, well, that's more active, that's being used during this task that's going on. And so we see those examples kind of in these highlighted areas of these larger activity regions because that blood is more oxygenated, it's drawing in more of those resources that it's being sent. And so we can see really fine grain where this is happening, and we can generally start to see when this is happening, but there is a bit of a delay in this response because that bold signal is a little bit delayed from when it actually takes place. And so we can use some equations, some predictions to try and figure out exactly when this is happening, but it is not a perfect one-to-one timing like EEG tends to have. So all four of these are different methods that we use to kind of see inside the brain and understand what's going on, and they have their pros and cons. Some are easier to use, like an EEG. Some require really large machines and complex sort of analysis, like an MRI or an fMRI. And so there are trade-offs that we must make when choosing kind of which one to use. But overall, I think they each have their place and their use case for us to kind of learn and understand a little bit more about how the brain works.